This video is on dividing polynomials by simplifying. We're going to begin by dividing a polynomial by a monomial. Remember, poly just means many terms. There could be one or more, and a monomial is strictly one term. So to begin, we need to review one of the rules for exponents, and that rule says that if you divide two terms that have an exponent, if the bases are the same, the rule is to subtract the exponents. For instance, if you had x to the power of 5 over x to the power of 2, your answer is x to the power of 5 minus 2, which is 3. Okay, so that being said, to divide a polynomial by a monomial, the first thing we need to do is sort of split this up into as many pieces as there are terms on top. This whole expression in the numerator, the top of the fraction, is being divided by this monomial 4x squared. That means that 16x to the 6th is being divided by the 4x squared. And the negative 12x to the 4th is being divided by the 4x squared, and the positive 4x squared is being divided by 4x squared. Now we take each fraction and we simplify it separately. So to do the first one, we look at 16 over 4, and that is 4 simplified. And we're going to use our rule for dividing terms with exponents, and since the bases are both x, we subtract our exponents and we get x to the power of 4. Since nothing is left in the denominator, we don't need a denominator anymore. We could put over 1, but of course we all know that anything over 1 is just the anything itself. For the next one, negative 12 over 4 simplifies to negative 3. And at this point, we're not sure if there's a denominator left yet, but anytime there still is, you would keep it. Again, bases are the same. Subtract your exponents, and we have x squared. Nothing is left in the denominator here. 12 over 4 is 3. 3 over 1 is just 3. For the last term, I see that I have an exact match on the top and the bottom. 4 over 4, remember, anything over itself is 1. And x squared over x squared, well, anything over itself is 1, but even if you didn't realize that and subtracted exponents, you'd get x to the power of 0, which by definition is 1. Here's the thing, you can't just cross them out and leave this blank. Anything over itself is 1, and you need that piece. However many terms you had to begin with, that's how many terms you will have in the end. The next example is dividing a polynomial by some other polynomial. And all we're saying is this applies to anything that's not just one term, because we've addressed dividing by a polynomial that's just one term. So again, there's a reminder of our rule here. Anytime you're dividing by more than just a monomial, you should look to see if anything in the problem can be factored. And if we look at this problem, I can look at the top and see that it has a 2 in common. Remember, when you're factoring, always look for GCF first. If I factor a 2 out of those, I'm left with x, don't forget, plus 1. In the denominator, I can't do anything to it, but I have an x plus 1 and I need to keep it. Now you look to see if there are any expressions in common. You can reduce fractions that are numbers, but you can also cancel out any expression over itself because it's equal to 1. Be careful. You can't just cross out these x's. Anytime something is attached to any other term by addition or subtraction, the addition or subtraction sort of locks it together. What I can do is cross-out matching expressions. So that x plus 1 can cross out with this x plus 1 because anything over itself is equal to 1. What I'm left with is 2 times 1, which is just 2. Nothing's in the denominator. If that 2 was left in the denominator, I would simply put a 1 as a placeholder in the numerator so that my answer would be 1/2. Let's look at another example, and this one goes a little farther. I'm also going to remind you about the negative exponent rule. This rule says that anything to a negative exponent is equal to 1 over that exact thing to the positive version of that exponent. Be careful, this works the other way around as well. If you start out with something in the denominator that has a negative exponent, you could move it up to the numerator and make that exponent positive. And that's going to be really useful when we do these. Let's take a look at this one. Again, we're not working with just a monomial, so we're going to try and factor. You'll notice that in the numerator, the leading coefficient is 1. And so I can use my trick and set up my parentheses, sort of a shortcut. I know my first positions have to be x, because x times x is x squared. And I'm looking for two numbers that multiply to 12, but add to 7. I hope you said positive 4 and positive 3. And of course, if we checked this and multiplied it back out by distributing, we would get the original numerator. So we know we've done it correctly. With the denominator, we notice we only have 2 terms. That means the middle terms canceled. And I hope you remember that if the middle terms cancel, that means that we should have the same thing in each of these parentheses, except one is plus and one is minus. That will cause middle terms to cancel. Again, my leading coefficient is just 1, so these have to be x's. What times itself would give you 9? I hope you said 3. Now, in order for the middle terms to cancel, one of these has to be plus and the other one has to be minus. Once you've factored everything that you can possibly factor, you should look to see if any expressions match from the numerator to the denominator. I notice that I have an x plus 3 on top and an x plus 3 on the bottom. Notice they don't have to be exactly underneath one another. Multiplication works the same backwards and forwards. So as long as we are just multiplying, it doesn't matter where they are. Now what I'm left with is x plus 4 over x minus 3. And so we'll write the x plus 4 over the x minus 3. The most common error here is to try and cross out those x's. Do not do it. Remember what I said. Anything attached to something else by a plus or a minus locks that term in. You can't separate it out and choose just to cancel that piece of the expression. The whole expression has to match. This is your final answer. You are done. Here are 2 practice problems that I'd like you to do as part of your notes, and we'll check them in class together. I would like to point out for this first one that I have an alternate way of writing a polynomial divided by a monomial. Dividing by 2x squared is more likely to be written this way down here, but you may see this and it might be helpful for you to rewrite it. Either way, it's talking about the same thing and you should recognize what to do for the problem. Pause the video, write these down, and on the next slide I'll have your summary. Okay, it's important to remember that not all polynomials can be simplified this way. And the reason is that not all polynomials can be factored. We are going to learn later in the course how to use long division and synthetic division to divide polynomials that can't be factored. When they can, the 2 things we need to remember to do when we're dividing a polynomial by a monomial, we're going to split it up and reduce each of the fractions. When we have a polynomial divided by another polynomial, we're going to factor everything possible, and we're going to cancel matching expressions only from the numerator and the denominator. Remember, do not cancel terms, look at entire expressions.